Hey everybody, I am going to explain the Leibniz theorem. So, what is the Leibniz theorem? If the two or more than two functions are given, so to find these two functions and derivative, we use the Leibniz theorem. But for a one function, it is not necessary to use the Leibniz theorem. So we use the normal n derivative. So for example, y is the function and this x is the variable. Y equals to left side function and right side variable. So y is the function and x is the variable. So it has only one function. So we know that first derivative y1 and x n minus 1, and similarly second derivative, again differentiating this, the result comes this, again third derivative, and further going so on. For nth we calculate this and derivative nth time, and result comes the n factorial, or we can write n factorial from here. So there is no necessary or need of the theorem. So for a two function there is necessary theorem. For example, y equals to x power 5, first derivative, we can do this by using power rule. Second derivative, okay, again differentiating second time, third time differentiating, and fourth time differentiating. Similarly the 5 time differentiating comes a 5 factorial. And in case of y sin x, after differentiating, in case of y sin x, we can say that so in case of y sin x, so differentiating dy by dx, it comes cos x. So we know that dy by dx, we can write that y1 equals to cos x, and we can write cos x as sin x plus pi by 2. We know that sin x plus pi by 2, it gives cos x 90 degree. So again differentiating this y2, we can get sin cos x plus pi by 2, and further we can change this in terms of sin x plus pi by 2 plus pi by 2. It will gives this. So again we can differentiate this, and y3 similarly it forms cos x plus 2 pi by 2, because this 2 form 2 pi by 2, this it will become result after third differentiation. So we can differentiate, because this is a single function, so we can easily differentiate to the nth derivative. But if case of this, there will be the two functions, so we use Leibniz theorem. So similarly for this y3, we can use sin x plus 2 pi by 2 plus pi by 2, it will give this. So similarly here we have just done. So for nth sin, because for third derivative y3 cos 2 pi y3, then it forms sin. In case of sines we have done sin 3 pi by 2 plus x. So in case of 3, here comes 3. In case of 2, here comes 2. So in case of nth derivative, here comes n. So we can find the n derivative of single function. But in the case of double function, we use here, we can find the n derivative of one function, but the n derivative of product of two functions. So we use the Leibniz theorem. So Leibniz theorem, if y equals to ub, where u is the function as ux, and b is the function of vx, and where x is the variable. So then after differentiating n derivative of these two functions, we will get a result 2 into second b n plus this c 1 power, and this is a permutation and combination where this c is this c. If c is equals to r n, then we can write as n factorial by r factorial into factorial n minus r. For example, c2, and then we can write as n by l2 into n minus 2. So we can write as this n equals to n minus 1, n minus 2 factorial, and l2 into n minus 2. This is cancelled, and the result will come here, n into n minus 1, n minus 1 by l2. So similarly, so we use this similar this to till nth, and where un is the n derivative of u and b, and is the n derivative of b. Similarly, this I've just explained above. This result came from here. Derivative of uv gives this again derivative of second derivative this. So further derivating the two function, we finally get the same result as above this. So this is the Leibniz theorem, the short and sweet explanation. Further on next lecture we'll discuss about the exercises. Thank you for watching my video.